Hello everyone and welcome to this video on oil cargo calculations part 3. In this part, we are going to look at the wedge calculations. The target audience for this particular video are the candidates appearing for phase 1 competency exams in India. In this module, we will cover the following topics. What is a wedge in oil tanker? How to decide if cargo ROB forms a wedge? Step-by-step procedure for wedge calculations. How to determine gross observed volume if the free water is present as a wedge upon completion of loading operations, and the varieties of the variations what we get in the wedge calculations in the examination papers. After completion of this module, you would be confident in attempting DGS phase 1 function 2 and its cargo work exam papers with oil tanker numericals. Now before we continue, please ensure that you watch the other two earlier videos on oil tanker calculations. Oil cargo calculations part 1 talks about the basics of the oil cargo calculations, the VCF, WCF, and some numericals based on that. Oil cargo calculations part 2 talks about the list and trim corrections, what we normally apply. So the list and trim correction is also part of your phase 1 examinations. So this also would be helpful for you in understanding the whole concept of how the cargo calculations are carried out. Now let us watch what is the effect of the trim on the oil surface. Now here we have a tank which is trimmed by stern, and this is the aft portion of the tank, there's a forward portion of the tank, and because it is trimmed by stern, we see that the aft sounding is more than the forward sounding. Because of the trim, the level of the oil always has to be horizontal, so the oil level is in this condition. The ullage of the oil can be found out from any length, but for finding out the actual ullage, what we call as a true ullage, we have to convert that ullage from that point to the mid length of the tank. This ullage is what is called as a true ullage. The reason because in case the tank was even keel, the liquid surface would be pivoting around this point. So we have an interest in finding out this particular level of the oil. From here we can find out what is the depth of the oil, and from there so on we can find out what is the volume and the metric tons and so on and so forth. In our earlier calculations, that is, and if you see in the videos in part 2, that is the trim calculations, the trim corrections what we apply, the oil level extended from the aft bulkhead to the forward bulkhead. When such a condition applies, we can use our normal formulas, and the true ullage is calculated at the middle of the tank. Now, when the oil surface comes down towards the completion of discharge or after completion of discharge, then we have an issue because the oil surface is no more touching the forward bulkhead. It is forming a triangular piece, a triangular section at the bottom of the tank. The oil surface starts from the aft bulkhead but does not reach the forward bulkhead. And in such cases, we have a wedge. So what is a wedge? When a tank is trimmed and the surface of the oil does not reach the forward end, it is called a wedge. If we have a wedge, we cannot use the normal formulas what we used earlier, because now when the trim is changing, or when the horizontal surface is not pivoting around the midpoint, it is pivoting around some other arbitrary point, which is not easy for us to figure out. And that is the reason why we cannot use a normal formula for calculating the height of the oil in the tank. And that is why we have to refer to what is called as a wedge calculation. Now this condition is happening at the completion of discharge when you have very little quantity of the oil. The similar condition can also happen when we have some during loading time also. Now in this particular example, we have oil loaded in the tank. The tank is trimmed by stern, so the aft sounding is more than the forward sounding. But we see over here, in this particular loading, we also have some free water. Because of the free water, the total quantity of the oil which is loaded cannot be directly figured out by taking the mid-length ullage and the mid-length depth of the tank. So that is the reason why we have to do this process 2 times over. In the first process, we have to find out the liquid surface if even keel, that is the ullage at the center of the tank mid-length. So the total observed volume can be found out by the regular formula. Why? Because the tank surface is touching both the aft bulkhead and the forward bulkhead. Once that is done, we have total observed volume. But the total observed volume has also got some component of free water. Now, how do we delete this component of free water? How do we find out this free water? For this, we have to separately do one more calculations using the wedge calculation, because this surface of the free water does not reach the forward bulkhead. it stops well before the forward bulkhead, and so the free water is forming a wedge. So once we find out the volume of this free water, this has to be subtracted from the TOV to get what is called as a gross observed volume, and from then on we can find out using the VCF and WCF as a regular method. Now, so the conditions for forming a wedge is that the oil surface does not reach the forward bulkhead. So we have this, the extent of the oil surface is dH, and this dH is less than dC, which is the length of the tank. So here we're talking about dH. If it is less than dC, then we say that it is a wedge. In the previous slides, we have seen the requirements for a wedge, in which all conditions a wedge is formed, and what are the requirements for a wedge. Now, just as a disclaimer, there are, as in always in all the other things in life, there are some conditions which apply over here also. Now, when you're talking about a wedge for examination, that is your phase 1 examination, the method what we are going to be talking about over here now, this holds good only when the vessel is trimmed but upright and it has got zero list. That is because only when the vessel is trimmed but with zero list, the surface of this wedge, the surface area of the wedge on the side, and also the shape what the wedge forms, it forms a regular shape. Now, if the vessel was trimmed and listed also, the shape of this wedge, what is formed at the bottom, will not be a regular shape. It will be something like a tetrahedron or a pyramidal shape. Now, finding a volume of that pyramidal shape in the limited time what is given in the examination is not possible, and that is why we don't go into that calculations in our steps in these. So the requirement for that is for our calculations in the examination is the vessel is only trimmed, but the vessel is upright, and zero list, no list at all. In the examination, if a sounding of a wedge and also list is given, generally it will not be a wedge problem. You can skip the wedge calculations and go ahead and use the normal calculations to find out what is the GOV, TOV, the volume of the wedge, or the volume of the water, free water, and continue with your calculations. Let us now understand the wedge diagram. So this is what we have, a tank ABCD. A tank ABCD, it is trimmed by stern. This is the forward section, this is the aft section, and the trim has caused this trim theta. Now this is trim theta in degrees and not in meters. We have a sounding pipe which is point U, which is located at a distance x from the aft bulkhead, and the sounding pipe has got an value h, that is the height from the tank top. Now whenever we find out these values, the LH tape is going to be suspended from this point U. So strictly speaking, we have to calculate all our calculations from this point U and not the tank top. Now let us look at the various things. So like we discussed, tank ABCD, that's taken care of. We have trim theta, and the trim is coming because of the trim of the ship. We are going to start our story from observed sounding. This is what we normally have when we are going for wedge calculations. This is observed by getting the value of this sounding. So we are going to drop one sounding tape from point U, the LH port, and it goes all the way down, and this is vertical to the oil surface. Remember, this UO or this UL is not parallel to the aft bulkhead. It is perpendicular to this oil surface. Oil surface is always horizontal, and gravity always ensures that this is always vertical. So it is actually going to form a right angle at this. It is going to meet it perpendicular at this point, the surface of the level GH. Next is what we are going to study about is, this is the observed. So what we have in hand is basically observed sounding. This can be obtained by sounding tape, by LH tape, by many other means, but that's what we have to start with. Next, what we have is the observed LH, that is UO. This point is what is UO, observed LH, and what is that is because it is called observed LH because it is what we get from this point of suspension U. If it is dropped, if the LH tape is put down, then we get this value UO, which is the observed LH. Next is the LH parallel to the aft bulkhead, UT. If you actually see this UT is parallel to the aft bulkhead, and that is what we are going to be getting it. Now, the next step is the height of the oil parallel to the aft bulkhead, that is TP. Now, this line TP is perpendicular to the aft bulkhead, so this forms the TP. Next is the DH, that is the extent of the oil spread in the tank from the aft bulkhead to how much it goes in the forward. And then lastly, the last component what we are going to be studying about is the height of the wedge, that is GD. So these are the various notations what we use for this wedge calculations. And my suggestion would be to retain the same notations. Of course, you can use any other letters what you feel like. But when you're going to be comparing the answers with your colleagues, with your batchmates and all, then if you're going to use the same letters, you can easily compare your answers and get to see where you're going wrong, and to just ensure that your steps are all correct. So retain the same notations. A, B, C, D is the tank, U is the point of ullage, and so on and so forth. Now let us see what is the procedure for understanding the calculating the volume of a wedge. So like I said earlier, what is given to us is OL, that is the actual sounding of the oil. From the OL, we have to figure out what is DH, that is the extent of the cargo spread. Why DH is because that is our first stop to figure out whether it's a wedge or not. So the whole story of finding out OL to DH is what is our wedge calculation. And this is a sequence of the wedge calculations as you see over here, our story from OL to DH. So we are going to be going step by step into the whole process. And this, what you're going to be seeing on this particular slide, is an overview of the whole process, and which we are going to be breaking up into smaller sequence as we go further down the slides. First one is the triangle ULP. The triangle ULP is right angled at P, and so from the value what is UP, which is known to us, UP is the height of the tank plus the height of the ullage pipe. From this value and knowing this trim theta value, we can find out what is the distance UL. Remember, UL is not equal to UP because it forms an angle, and the angle is formed because of the trim of the tank. Next step is to find out, once we have this UL in hand, we already have OL with us, which is given in the numerical. So next what we have to find out is UO, that is your observed ullage. So UO is equal to UL minus OL. The next step is to find out what is this ullage which is parallel to the aft bulkhead. Now to find out that, we are going to skip the triangles. We are going to change over to the new triangle. So the triangle is UOT now. In the triangle UOT, we have this trim theta, and we also have this number 2, which is UO. So using these two values, we can find out what is UT. Okay. Now, once we know UT, we already have this UP, which is the total length of the height of the tank plus the height of the ullage pipe. So we already know that value, and so we can easily find out what is TP. TP is UP minus UT. This is the sounding of the oil which is parallel to the aft bulkhead, and that's our step number 4. In step number 5, we're going to find out using the small triangle TPH, which is right angled at point P. Why it's right angle? Because this line UP is perpendicular to the tank's bottom, and it is parallel to the aft bulkhead also. So this triangle is right angled at UP, and this theta, the angle what it forms is theta, which is again the trim theta. So from here we can find out what is pH using trigonometrical ratios. Once pH is known, we can find out the value for dH. And how is that? dH is equal to dP plus pH. dP is same as UO, which is the distance from the aft bulkhead of the sounding pipe. And now once we have the value for dH, then we can figure out if it's a wedge. And what is the same? What's the relation to that? If dH is less than dC, that is, if the extent of the oil, the spread of the oil in the cargo tank, this dH is less than the dC, which is your length of the tank. So once we know that, okay, fine, it's a wedge, it meets the criteria, then we have to go and find the volume of the wedge. How do we find the volume of the wedge? Is from DH, and using this large triangle GDH, we are going to find out the value for GD, that is your sounding at the aft bulkhead. The height of the oil at the aft bulkhead, you can say that. Now that is used, GD is used, and DH is used, and from there we can find out what is the area of this triangle. Area of the triangle multiplied by the breadth of the tank will give us the volume of the wedge. So this is a process of wedge calculations from OL to DH and further on to find out the volume. Now let us break up this process into smaller triangles, into smaller sections, and see one by one as to what is happening. Now if you remember in this previous examples, what we have used is trim theta. Now remember, trim is in angle and not in meters. So if you remember from the oil calculations in part 2, we had reduced trim in meters, which is our normal formula is aft draft minus the forward draft. and here we have formed a right angle triangle. So tan theta is equal to trim by LBB. So theta is equal to tan inverse of trim by LBB. So wherever theta comes in our equation, I can superimpose it by tan inverse of trim by LBB and go on with my calculations. Now we come to the wedge calculations in details, step number 1 and 2. So in step number 1, we are going to go with this triangle ULP. Remember, what is given to us is OL, and that's all is given to us. We have to find from the OL, we have to find out what is DH. So from the triangle ULP, which is right angled at P, this theta is the trim theta. So cos theta is equal to UP upon UL, which is the hypotenuse. Now from that we can find out what is the value for UL, the total length from the ullage pipe to the bottom of the tank, but it is not equal to UP. It's actually a little more than UP. So UL is equal to UP into secant theta. That is our first step. In this UL, what we already know is OL. So from there we can find out UO. That is our second step. So we find out what is UO, and UO is nothing but UL minus OL. So from this large triangle, in 2 steps, we have found out what is UO. That is, in other words, observed ullage. Now, going further, in the next triangle, we are going to consider UOT triangle, UOT, which is right angled at O. We already have the value of this UO, the observed ullage from the previous step. Using this triangle, and we know that this is angle theta, which is trim theta, we can find out cos theta is equal to UO upon UT. UT is a hypotenuse over here. What we want to find out is UT. So UT is equal to UO into secant theta, and so from here we can find out what is the value for UT. We already have the value for UP, which is the height of the tank plus the height of the ullage pipe. So once we subtract the height of this UT from this UP, what we have in hand is now step number 4, which is TP. So in the second step, in 3 and 4, we are going to find out this vertical height, or the height of the oil, which is parallel to the aft bulkhead and from the ullage port. Alright, so in our step 2, we have reached till point 4, which is the height of TP. In the next further steps, we already have TP, and we are going to consider this triangle TPH, which is right angled at P. Now tan theta is equal to TP upon PH, and from this value which is known, tan theta is known to us and TP is known to us. So from here we can find out what is PH. So what is PH? This value PH is equal to TP upon tan theta, and from there we can find out this value. The next step is, once we know PH, we can add the value of the distance from the aft bulkhead of the ullage port, and we can find out what is DH. So in the next step, what we are finding out is DH, which is DP plus PH. This is what we actually started off, the value for DH. And why the value for DH is important to us is because that is what decides whether if it's a wedge. So if DH is less than DC, that is the length of the tank, it forms a wedge. Now in our calculations in the examinations, please make this statement very clear that it forms a wedge. It's very, very important that you specify it over there, so that it is very clear that it is forming a wedge, and that is the reason why we are doing these calculations further on. Now, the next step is, once we declare that it's a wedge, next is to find out what is the volume of the wedge. Now, how do you do the volume of the wedge? For finding out the volume of the wedge, we want to find out what is the value for GD in the triangle GDH, that is G, D and H, which is right angled at D. We know this trim theta, and we also know what is DH. Using these 2 values, we can find out what is the value for GD. And that is our last value in this whole calculation of the wedge calculation, which is GD is equal to tan theta into DH. Once we have GD and DH, now we can easily find out what is the area of this triangle. So what is the area of a triangle? The formula is half into altitude into base. That is, area is equal to half into the altitude, which is GD, into base, which is DH. So from here we can find out what is the area of this triangle which is marked over here. Once we find out what is the area of this triangle, we can multiply that by the breadth of the tank, and this becomes like a three-dimensional picture now. So the breadth of the tank, and then we get the volume of the wedge. So to find the volume of the wedge, the area of the triangle GDH, which is marked in brown color, into the breadth of the tank. So here finally I've got the volume of the wedge now. Now if the volume of the wedge is water, we can subtract it from the total observed volume. If the volume of the wedge is oil, we can multiply with this oil by multiply this further on with using the other factors to find out from the volume to metric tons. And the procedure for that is first find the VCF of the oil at the observed temperature. From there you find out what is GSV, which is observed volume, into the VCF. From there, we've multiplied this particular factor, whatever we get, this GSV value, we multiply that by density in air, and then we get what is called as a weight in air. If it happens to be a free water condition, like in this particular case, we can subtract the value of the free water, the volume of the free water, from the total observed volume, and we can easily find out what is the actual amount of oil loaded. And the total observed volume, as we discussed earlier, can be calculated by the normal formula. The trim correction formulas can be applied and found out because the oil surface is touching both the aft and the forward bulkhead. Okay, if the free water is a wedge, we have to deduct it from the total observed volume and get what is called as a GOV. From the GOV, we can calculate GSV and metric ton in air. Okay, the procedure of calculating this GOV to GSV and to metric ton in air is already explained in the second part of the volume, and we also saw it in the previous slide of this series. Now, this is the whole thing. So as a summary, our story of wedge calculation is to find out from OL to DH. And to make it simpler, to make things simpler, there are some easier way to understand the progress of it, because you're going to be talking about 4 triangles. Sometimes it becomes confusing. Triangle UOT, triangle TPH, GDH, and all these triangles. So as a simple way to understand this triangle is to break it up into smaller pieces. So we're going to break it up into 4 key points. The first one is the sequence of the triangles, as we call it. The first one is a big standing triangle. And what is a big standing triangle? ULP. So this is a big standing triangle, what we're talking about, from where we find out step number 1 and 2. Next is small standing triangle. Where is the small standing triangle? That is UOT. That's our small standing triangle. From there we reach up to step number 4, because we can go from number 2, which is UO, to UT, and from UT we can find out what is TP. Subsequently to that, we are going to refer to the small sleeping triangle, like a sleeping triangle, horizontal triangle. That's a small triangle TPH. From TPH we can find out what is PH. From PH we find out DH, and DH is the one which decides whether it's a wedge or not. And if it does become a wedge, then we go to the next step, the large, that's a big sleeping triangle, which is the GDH triangle. So this is an easy way to remember. Large standing triangle, small standing triangle UOT. Next is small sleeping triangle TPH, and the big sleeping triangle GDH. Once you do a couple of numericals on this wedge calculations, you don't have to worry about this large, big, small triangle sleeping and all that stuff. That automatically come to you. But initial process, the flow, if you get it wrong, then it becomes very, very difficult. So this is just as an aid for memory as to what is the sequence of triangles to be performed. Now this is all the calculations about the wedge calculations from GD and from DH. We find out what is the volume of the oil or the volume of the wedge. If the wedge is a water, subtract it from TOV to find out to GOV. If the volume of the wedge is actually oil, which is the ROB, then we can multiply that by VCF and WCF and find out the weight of the oil. Now there are some small variations in this whole process. The variation is basically the kind of value what is given to us. That is the value of the OL or sounding or something like that. The base problem is, if the tank sounding is given using a sounding rod, that means OL value is given. That is what we solved all this while. So if OL is given, we have to go all the way. That is step number 1, 2, 3, 4, 5, 6, and 7, and use the 7 and 6 for calculating the volume of the oil of the wedge. Now the second variation is if an allege tape is given. That means if the tank allege is given using allege tape, that means what is given to us is UO and not OL. If that is so, if UL value is given to us, that means I don't have to do the step number 1 because we already have UO in hand. So in such cases, UO is directly given. So we are not going to do this step number 1 and 2. We can directly skip step number 1 and 2 and go to the step number 3. So we don't have to do these two steps, and we can proceed as usual from step number 3. So if you have given what is the value for allege tape, that is the tank allege towards a completion using an allege tape, then please don't do step number 1 and 2. You can do over this whole problem, the whole numerical, from step number 3 onwards. The third variation what can be given to you is the tank allege using tank radar. Now, as you all know, tank radar always gives the allege which is parallel to the aft bulkhead. That means what is known to us is the value UT. UT is our step 3. That means this particular value is known to us. In such cases, when UT value is given to us, we can skip step number 1, step number 2, and step number 3, and directly proceed over to step number 4. From step number 4 onwards, it is a regular procedure. So depending on what kind of which means we use for finding out the remnants of the oil, our calculation, our steps will be kind of like truncated, or if it is the observed sounding is given, then it is all the way from 1 to 7. So if the tank allege is from the radar tank radar is given, then we proceed as usual from step number 4 and go on with the calculations. So this is all about the wedge calculations. Now we know it. The conditions for the wedge is oil surface does not reach the forward bulkhead and the value DH is less than DC. So now you should be confident in opening up the examination papers. Go ahead and solve those questions. There are a lot of publications already available which talks about all these wedge calculations. Some are solved and some give you some exercises and all. With this knowledge, you should be able to attempt the MMD papers and crack them out. Thank you very much for watching this video, and I hope you enjoyed it as much as I enjoyed making them. Thank you very much and all the best for your examinations.